Alright, so here's what's going on. I've done countless hours of testing this and getting all the info of what's happening. So I'm going to explain what's happening in this coil setup I have going on. I don't know where to take it next. I feel there's a step or two more needed. But anyway, let's go through it. I will update and show live demonstrations of all this part at a time, but it gets quite confusing, and it took me a little while to figure out what's all going on here. Okay. So, as you saw in my setup, when I'm pulsing my coil setup, I'm using 12 volts in, and I'm getting 27 volts on it. Okay. So, on a standard generator, right, this is a rotor spinning the north pole. When the north is going away from the coil, nature wants to stop the magnetic field switching and stop the rotation. Okay, it wants to balance that out. It wants to neutralize it. So what does it do? If north is going away, the coil goes south, right? And now when that happens, it sends power. I don't know about the right-hand rule, left-hand rule. I didn't make my coils exactly perfect, but it sends power that way, basically. And then it slows rotation, your drag. Everyone knows this. Okay, now the setup I'm dealing with. Okay, so we're putting in 12 volts. Power is coming in. It's going through the coil. Okay, now we have a full magnetic field already built in that coil, right? Let's say this is north, right? So we have a north field. Now there's another coil underneath. What's that going to do when there's a changing magnetic field in a coil and it's inside a core, right? It's going to try to neutralize it, right? So what does it do? It ain't going to make another north here, or else it's going to increase the magnetic field. Two norths make more north. So no, it's going to try to stifle that down. So it's going to create, in this coil, it's going to induct a south, right? But when it inducts a south, what way does south send? That way. The same way as the input. So when this coil grows, magnetic field, because the current's going through it, this one's inducting, trying to stifle it. And when it's trying to stifle it, it's sending current in the exact same way as long as the two coils are set to attraction mode. Then, vice versa. When this goes down here and starts making a south pole, right? Because that's the way we have the coil set up. What's the top one going to do? It's going to induce back into the top one, what? North. Further making voltage flow in this direction. So this whole thing, you're actually creating back EMF, but we're confusing it, and it can't stifle both of them. It can't stifle the voltage and the magnetic fields at once, either one or the other. So it stifles the magnetic field, and by doing so, increases the voltage. So when you probe on either side of a diode, my power supply is putting in 12. I'll probe here, I'll have 12 volts. Then I'll probe here, and I'll have 27 volts. Over 2.5 times the terminal voltage of back EMF going the correct way. It's awesome. Now, amperage, I'm not sure what's happening with that. I can't wrap my finger around it, and I can't get it to go over unity by connecting stuff in between or putting a coil here and trying to induct from it. I almost get unity, but I can't go over unity yet. I'm missing something, and I think it has to do with power factor of voltage. But anyway, that's that setup. Now let's go to motors. So I started connecting this on a motor. Now basic motor stuff, right? Here's your rotor, north and a south. It's spinning this way, okay? So now people might not know this, but you could do this yourself if you have a pulse motor or a little motor, right? Take your power supply and let the volts run. Don't lock the volts. Let it go as high as it wants, but lock the amps, right? So I'm going to lock mine at 5 volts, and then, no, I'm not going to lock voltage. I'm going to let voltage free. I'm going to lock it at 200 milliamps, 0.2 amps, right? And then when it gets up to speed, as back EMF starts dropping this to 0.2, 0.1, the voltage is going to go up. You'll watch your power supply voltage go from 5 volts, 7 volts, 10 volts, 15 volts, 20 volts, 30 volts, and the voltage goes up as your back EMF is making your amperage goes down. Now, you might not believe that, but go ahead and test it. You'll see. Okay, so why is it doing that? It's doing that because as the rotor is going this way, north is leaving. Let's just take this scenario. This will turn south. South is going to send, even though you're sending current in this way, south is going to send, the back EMF is going to go this way. And both the voltage and the amperage are both going this way. So therefore your amperage is going down because you're beating your amperage. Now, your voltage goes up on a power supply because also it's equalizing out your voltage. So in order for your power supply to keep speeding it up, or to keep to compensate for the back EMF, it needs to put out more. So this is sending 5 volts back EMF. Your power supply has to go up by 5 volts in order to compensate for that. And that's why it's going up. Now, if you probe, put a multimeter here and here, if this says 15 volts, your power supply says 15 volts, you'll have 15 volts here, and you'll have 15 volts here. The power that your power supply is telling you is actually coming from the supply. Now, how to beat that? This little rig. I've done it. Okay, so power supply comes out. I'm just drawing a diode in here so you could probe. You draw a diode in here, throw a diode for now. Right? In reality, you'll have it before your H-bridge or off your battery or whatever, because you have to switch polarities. Now, this is switching polarities on a coil, which is driving your rotor. Right? Then out of the coil, you go through the 2 attraction coils, a transformer in attraction connected. Right? And then back to your battery. Now, or power supply. Now, when you're in this configuration, this action right here from your power supply going through here is causing this to happen. It's causing back EMF to flow all in the correct direction. It's causing that. Then this is just making your rotor spin. Now you will probe now, your power supply will say 12 volts here, and here you'll see 20 volts. Now this increase in volt isn't coming from the power supply, it's coming from here. Again, how this relates to over unity, I'm not sure. There's some amperage stuff to figure out. But anyway, that's the basic philosophy of what's happening there. I have a feeling something about power factor and lagging amperage and whatnot. I'm trying to wrap my fingers around that part and figure that out, but that's where we're at. And again, I will make some demonstrations to show all this at a future date soon.